Good morning, afternoon, or evening, whenever you happen to be accessing this. This is Mrs. Allen here, and we are looking at differentiating inverse trig functions today. So what I'm going to do is I'm going to just get out the bouncing ball here and get started. So we've got a quote from the AP exam on notation. That this came up in the last test where I was discussing how you're writing your information out. The inverse trigonometric function x may be indicated using the inverse function notation f inverse or arc, if you like. So you have to denote it somehow, like this or like that. It means the same thing and is equally respected. So let's go over the derivatives now. This is, remember, in the last section we were dealing with the derivative of an inverse function in terms of notation as well, but just any old inverse. Now, if we're looking at this, we have the derivative of sine inverse. It's going to be equal to 1 over the square root of 1 minus x squared. So this is a form. The derivative of secant inverse is 1 over the absolute value of x times the square root of x squared minus 1. And then the derivative of tangent is 1 over x squared plus 1. Now, when we're in class, I'll discuss some of the ways that we're able to memorize these. But if you look at this, the cos, remember the derivatives of cofunctions are negative. So when we take the derivative of these three, they're all going to have this negative sign in the front. Okay, and they're the same as the derivatives of their cofunctions, if you will. Well, inverses, but the derivative of cosine inverse is just the negative of the derivative of sine inverse. The derivative of cosecant inverse is the derivative of secant inverse, but just negative, okay? So the derivative of cotangent is just the negative of the derivative of tangent. So easy to kind of remember these, and you see the cofunctions, how they are working together. Okay, that's why I listed them the way that I did. Okay, so let's try this first problem here. So if we want to find the derivative, and I'm just going to go right along here. So this is an inside function of 3x. So I'm going to use the derivative form for the derivative of sine x. And so with this, I'm going to use the u prime. You could use the u prime over the square root if you wanted to, but I'm just going to go ahead and do the chain rule. So it's 1 over the square root of 1 minus u squared times du dx, and here you see the u is equal to 3x, then the du dx is 3, and then also noting that u squared, since I need to use that in the formula, is then 9x squared, so I just plug it in instead of putting 3x, the quantity, squared. Okay, so we got this for our answer then. Okay, so it's just pretty much plug and chug. Derivative of tangent inverse is, again, another u sub, because you have 2x squared, so u is equal to 2x squared, du dx is equal to 4x, u squared then is equal to 4x to the fourth. So when I plug in, here's my derivative of tan inverse, 1 over u squared plus 1, and then times the derivative of the inside function, du dx is 4x. Plugging things in, I get this, 4x over 4x to the fourth plus 1 is the derivative of tan inverse of 2x squared. Arc secant, you see the form right here of the derivative of arc secant, but we use a u instead of x. And then we have 1 over the absolute value of u times the square root of u squared minus 1 times du dx. So we said our u is 5x, du dx is 5, and then our u squared is 25x squared, and we just plug everything in. So you can see you have your answer here, but if you notice, I was able to, since my du dx was 5, I was able to take this absolute value of 5x and split it up using the absolute value rules. 5 is always positive, so the rule says the absolute value of a product is equal to the product of the absolute values, and you see that we have a 5 and a 5 here that can be canceled then. And so we get our final answer here. Okay, for number 4 and number 5, this is just simplifying expressions. Sometimes students need a little bit more work with simplifying the absolute value, so that's all I did here. So if you're looking at the numerator and you have 3x cubed down at the bottom and you have 9x squared in the top, what I'm doing is I'm factoring out the quantity 3x squared, and you can see that we can take the absolute value of each one of these, separating the product, and the absolute value of x squared is still going to be x, but then we have the absolute value of x is the only one that we have to keep inside. So then we can really just keep that denominator, since the 3x squared cancels with a 3x squared up top. The top becomes 3, and the bottom is the absolute value of x times the square root of 9x to the 6th minus 1. So much easier to deal with it. And we need a little bit of work on simplifying lately. It's been coming up. So then with this next one, we have the same kind of situation. You can pause your video and look at this then. And you can see that the denominator really has a 2 in it, 2x squared. And then we can simplify it. I'm just looking at this real quick. I have the absolute value of 2 times the absolute value of x squared, so it becomes 2x squared, and then we have a 2 goes into the 4, and we still have an x left in the denominator because the x's will cancel. This x will cancel with that, and we just have this answer. Okay, so then we have unit circle domain of inverse functions. So the domain of inverse functions, you can see that the sine inverse is going to go from -1 to 1. That's your range. It covers all the trig function values. But then the range is only going to go from negative. Notice we say negative pi over 2 to pi over 2 up here. So this down below, negative pi over 2 to keep them in order. And then you're going this way. Okay. Then the domain and range for the cosine, you're covering all the trig function values here with the cosine, from -1 to 1 in quadrants 1 and quadrants 2. So that's one more thing I think I'd like to add. Let me take this out, that we have quadrants 4 and quadrants 1. And here we have quadrant 1 and quadrant 2. Covers all the values from -1 to 1 for the cosine function, because cosine is positive in quadrant 1, negative in quadrant 2. So that is those are the designated, that's the designated interval, quadrant 1 and quadrant 2 from 0 to pi for all. It's called the principal values for cosine inverse. And then you can see that the range is going from 0 to pi. Okay. Then remember, the range in this case is going to be an angle, because remember that the sine inverse really is red. The angle y, whose sine is x. Okay. So we're actually putting the ratio. Remember, this x is your ratio. And then the y is going to be your angle. Okay. So enough said there. Okay, so then the last one, tan inverse, is again quadrant 1 and quadrant 4. All of the angles, except you notice I have holes on the end. You can't use pi over 2 or negative pi over 2. With negative pi over 2, you will not get any value because tangent is undefined at negative pi over 2 and pi over 2 up top. Okay, so remember how you read certain things. The angle whose sine is root 3 over 2, and you know what that is. Root 3 over 2 has got to be 2 pi over 3 and pi over 3, right? The angle whose cosine is -1/2, for instance, is going to be 2 pi over 3. Okay, anyhow, so enough of that. 3 more examples that I have for your homework before you begin your practice is that we want to evaluate each function at the given value. So you can see that if we plug in root 3 over 2, it's the angle whose sine is root 3 over 2. I just mentioned this. So it's going to be pi over 3. Only one value in this case, the principal values. Okay, the angle whose sine is root 3 over 2. So that's the y value, only one value. That would be a quadrant 1, just quadrant. Oh, I just put in a 2 there. Yeah, Roman numerals, whatever. So quadrant 1 angle. I should actually put a little q in there, okay? And then for the second one, cosine inverse x over 4 at x is equal to -2. We plug in the value, -2. We get the cosine inverse of -1/2. So we get 2 pi over 3. You can kind of see where I marked it on the above unit circles. So the angle would be 2 pi over 3, a quadrant 2 angle where cosine is negative. Okay, and then the third one, the angle whose tangent is 1 over root 3. Now you could rationalize this and say root 3 over 3 if you wanted to, but it's still going to be pi over 6, and you see the angle here. And you can find that pretty easily. If you look, you have a complex fraction set up like that. 1/2 is your y value. Y tangent is y over x, so it would be 1/2 over root 3 over 2, and you simplifies to this, okay, because you could just cancel out the 2's here. So you get pi over 6. So that gives you the values. Now, the homework and the practice is assigned for tonight. But again, tomorrow's a work day, so we're going to work on some of these problems in class, more than likely. And so finish this up and make sure you get to the test prac. Always making sure that you, as you do your U sub, if you need to take those steps and say U is equal to this and du dx is equal to, and make yourself a list. But remember, the big issue with this last test was organization. And once we get the organization down, it'll follow us all the way through the class. So have a great day, and I'll see you when I see you. This is Alanator out.